Hi and welcome back. Last class in integrated science, we began looking at thermometers and temperature. So we would have looked at the laboratory thermometer, and for homework, I asked you all to go through the clinical mercury thermometer, the minimum and maximum thermometer, as well as digital thermometers. So I'll go through it briefly just to point out some of the things that you need to take note of, and then we are going on to evaporation. So the clinical mercury thermometer, it's designed especially for measuring the temperature of a living person. Very important to note that. Alright, now you want it to be more accurate because body temperatures do not vary in large quantities. So why do we need to use a thermometer that goes from 0 to 100? Where we can use a smaller scale or a smaller range of values. So clinical thermometers go typically from 35 degrees Celsius to 43 degrees Celsius. So that way it is in close range with the normal body temperature. And our normal body temperature is around 37 degrees Celsius. So you can take note of that. Normal body temperature is 37 degrees Celsius. The range of values for a clinical thermometer is 35 degrees Celsius to 43 degrees Celsius. Another important thing to note is that this interval between each markings on the scale is 0.1 degree. So a very precise reading is obtained, meaning that a very small change in body temperature can be detected by the clinical thermometer. Another special feature of a clinical thermometer is this little constriction there, right? What the constriction does is that when the bulb is removed from the mouth or from under the arm or wherever the temperature is being taken from, the rapid change in temperature causes the mercury to start contracting very quickly, right? So by having this constriction, when the mercury in the bulb starts to contract, it will break the flow right there at that constriction, and the mercury that is in the tube will remain as is. So that way you are able to take the reading. You have enough time to read that reading. It wouldn't just flow back into the bulb directly. What you do have to do to basically reset the thermometer is that you will give it a little shake and it sends the mercury back into the bulb. So if you were ever by the doctor and your temperature was taken with a typical clinical mercury thermometer, you would have seen them shaking the thermometer before they are going to take a reading. And that's just to make sure that all of the mercury is back in the bulb before they start taking a reading. Alright, so all 3 points here are very important to note of those features, and most importantly the range of values that a clinical thermometer has. The maximum and minimum temperature thermometer, it basically used to tell you the minimum temperature reached and the maximum temperature reached over a particular period of time for a specific place. Right? So this reading here is going to give you the maximum temperature reached, whereas this reading here is going to give you the minimum temperature reached. If you want to get the current temperature, you have to read the mercury scale. So if you look at it on this side, it says 20 as well as on this side, and that is your current temperature. So your current temperature can be read either from the left or right because it will read the same, but the minimum temperature is read below the Steele index on the left, and the maximum temperature is read below the Steele index on the right. Alright, so it's a very useful tool if you want to measure temperatures over a period of time. Digital thermometers, very popular now. There are many different types, many different brands, they work in different ways, right? But basically they will have some sort of a sensor, and these sensors will produce currents which are dependent on temperature, and the value that they get will be displayed on a digital screen. So you'll see 35.6 degrees, 29.5 degrees, 37 degrees, and so on. Now we are seeing a lot of digital thermometers. Being that we are in the pandemic, your temperatures are taken at most establishments, right? And they use the digital ones. So you'll see a digital value on it, right? Now these are typically used in furnaces and underground to measure temperatures of soil. Right, you can have electrical wires leading from the sensor to your display. So, right, you can bury it deep into the ground to measure the temperature low below, and you will have the digital display above ground. Right, they are very good because they will respond quickly. They don't contain any toxic materials, and they are rapidly replacing clinical mercury thermometers. Right, as I was saying, as we see here, right, you don't see when they're testing your temperature they're using a clinical thermometer, right? They use those digital ones that has a sensor and it's going to read your temperature. So for today's class we'll be focusing on evaporation and the cooling effect that comes with it. So firstly, you want to take note of the definition of evaporation. So evaporation is the escape of molecules from the surface of a liquid. Now, when these molecules escape the surface of a liquid, the temperature of the liquid decreases. So let us see why. In order for a particle to break free of the bonds in the liquid state and evaporate into the gaseous state, it needs to have a certain amount of energy. So the most energetic particles or molecules in your liquid is what will escape from the surface of the liquid. It's very important to note as well that evaporation only happens on the surface. So you could note that evaporation only occurs on the surface. Right? So do not confuse evaporation and boiling. Boiling will happen throughout an entire liquid and at a specific temperature, depending on the liquid that we are dealing with. However, evaporation can occur at any temperature and it occurs only on the surface of the liquid. So it's very important to take note of that. So what happens is that the molecules, in order for them to gain enough energy to escape the bonds of the liquid state, they will absorb heat energy from other molecules. So once they absorb enough energy, they will have enough energy to break through or to overcome the attractive forces which exist between the molecules in the liquid state. Once they attain that energy, they are able to break free. Now, when they are leaving, this energy is known as the latent heat of vaporization. So once the particles leave, they have already taken that amount of energy from neighboring molecules. So now the temperature of the entire body will decrease. The opposite happens during condensation. During condensation, latent heat of vaporization is released and the attractive forces are no longer overcome. So they are forced to be in that state. The temperature of the surroundings therefore rises. So once evaporation is happening, the temperature of the liquid is going to decrease or it's going to cool down because the particles need that extra energy. It's taking that extra heat energy from nearby molecules to pull away from the surface. Right? Another example of the cooling effect of evaporation is in sweating. When you are exercising, right, your body is going to be heating up, and our body's natural response to maintain our body temperature is to cool down. So in order to cool down, we sweat. When we sweat, we get rid of some of that extra heat energy. So that is what this little paragraph is going to explain in a little bit more detail. So chemical reactions are constantly occurring in our bodies. These reactions are necessary to maintain life and are called metabolic processes or metabolism. The metabolic rate is a measure of the amount of energy used by the body per unit time to sustain itself and to carry out all of the activities. This energy is provided by the process of respiration. So if you forgot what is respiration, please look it up. As metabolic reactions take place, heat energy is released. All right. So once these processes are happening, we have heat being produced by respiring cells and we will become hotter, right? Which is why when you are exercising, you tend to see that profuse amount of sweating because your body needs more energy in order to carry out that extra physical activity. So your body is going to be respiring more to give your cells more energy, and as a result, more heat energy is going to be released. Our sweat glands then release perspiration, which we know as sweat, on evaporation, and it removes heat in that process as well, which helps us to feel cooler. Alright? Now there are several factors that affect the rate of evaporation. So we're going to look at those 4 factors. The first one is temperature. We know that the higher the temperature, the more energy the particles will have. Right? So typically, molecules will move faster at higher temperatures. And if they are moving faster at higher temperatures, they have more energy at higher temperatures. They also have a better chance to overcome the attractive forces in the liquid state and escape as a gas. So higher temperatures tend to allow for a faster rate of evaporation. Next is humidity. If the humidity is high, the molecules escaping from the surface are more likely to crash into other molecules and rebound into the liquid, which will reduce the rate of evaporation. Wind, very important one. This removes molecules from above the surface, allowing evaporating molecules to have a better chance of escaping without colliding and rebounding to the liquid. Right, so the wind will basically be blowing off those particles that have high energy. So they're right there waiting to escape, and the wind just gives them that extra push to leave the surface of the liquid. So in windy areas, you will have more evaporation happening. And the last thing is surface area. Remember, in the beginning, I told you that evaporation only happens at the surface of a liquid. So the larger the surface area, the higher the rate of evaporation will be, because there's a larger surface where the molecules are exposed to. Right? So a large surface area allows more molecules to escape from it, thus increasing the rate of evaporation. Right, so the last part that we will be doing today is ventilation. So ventilation is the process by which clean air is intentionally provided to a space and stale air is removed from it. In order to keep us healthy and comfortable, the air around us should have the following properties. We should have an adequate oxygen level, adequate humidity level, be at an adequate temperature, be free of dust, pollen and toxic contaminants, be free of mold and bacteria. Alright, so we know if you go into, let's say, an old house, or if you have a room in your house that is constantly closed up for a long period of time, think about when we could have gone on vacations and stuff, and you lock up the house and you go for a week or 2 weeks. When you come back home, you feel that very stuffy, dusty feeling. The house would not necessarily smell bad if it's for a short period of time, but if it's closed up for a long period of time, you're gonna get that really, really stuffy, dusty feeling. Think about how long ago they used to have these little sheds, your parents or your grandparents always have an old little tool shed outside, closed up. It's not properly sealed off and stuff like that, so sometimes a little rain is beating in, so you get a little mold build up. Inside there is gonna smell moldy, you're gonna smell that stuffy feeling, that dusty feeling. That is because it does not have proper ventilation. So once you have a place that is properly ventilated, we are going to be more comfortable, right? So that is why we say ventilation is the process where clean air is intentionally coming into a place and you are letting the stale air out. By opening up your windows, opening up your doors, you let out that stale air and you allow clean, fresh air to enter your room and your surroundings. Right, so we're going to look at some of the problems of inadequate ventilation of enclosed spaces. As we breathe, oxygen levels fall and carbon dioxide levels rise, right? That is because as human beings, we need to breathe in oxygen and release carbon dioxide in order to provide energy for our cells in our bodies, right? So now if we are in a closed up room for a long period of time, now it takes a little while, eventually it's going to make respiration difficult because of that lower level of oxygen and a higher level of carbon dioxide, right? Think about if you are in a locked car without the air condition running, no ventilation. Eventually you're going to get very stuffy in there. It's going to be very difficult to breathe, right? So it's something to take note of. Exhaled water vapor causes increased humidity, reducing the cooling effect of evaporation. Right, so that's why as well on humid days you tend to feel very sticky because the reducing of the cooling effect due to high humidity levels. Microorganisms such as mold rapidly multiply in warm, humid environments, creating an unhealthy, musty odor. So that musty odor is that closed up, that very claustrophobic feeling you get in a room that has been closed up for a long period of time. Toxins and dust can interact negatively with our bodies. So providing adequate ventilation, you all can read through this on your own, right? Enough windows on different sides of the room, right? You can open them up, you can have fans to help bring in cool air condition which will pull out warm moist air and replace it with cool, less humid air. There's also dehumidifiers which will lower the humidity level. Dehumidifiers should be used in highly humid rooms such as cellars. Humidifiers should be used in rooms where the air is very dry. Right, so next class we will continue with the effects of high humidity and the effects of low humidity. So you can begin reading up on it and we'll go through it very briefly in our next session. If you all have any questions, please feel free to comment it on our Google Classroom wall and I will address the issues. I hope this video was helpful and that you are understanding as we are going along.